Hi, my name is Franny Saikon and I'll be talking about React PWAs in three different ways. Let's get started. First, let's define React. React is actually one of the famous front-end libraries out there, built and open sourced by Facebook. In the official docs, it's defined as a JavaScript library for building user interfaces. Before proceeding, let's dabble on the word library. React is not a framework, no matter how many articles you read that says it is. Technically speaking, it's a library specializing in managing your application's view. It doesn't have its own router, API fetcher, nor even an opinionated way on how you should do your styles. It's just a library, a piece of the puzzle. I've listed several key points in what React is. React takes advantage of JSX, or JavaScript XML. This is used to describe to React how your HTML structure will look like. This is actually optional, believe it or not, but the React way highly encourages you using it. React makes use of the virtual DOM. This virtual DOM serves as the main mechanism of React to determine which parts of the physical DOM should change whenever there's a state change, either triggered by a button click, a successful or failed API call, etc. React follows a one-way data flow. This describes how React manages your data across the platform. A child can never see the data of a parent unless the parent give it through context or props, one of the many React APIs that lets you share data across components. This makes your data predictable. React uses hooks, only in newer versions though. These are functional APIs that lets you access different lifecycle methods that React internally has. For the scope of this talk, we will only use hooks, as in the previous versions of React, we do lifecycles in a different way. In my opinion, hooks made everything easier. Why would I choose React? For simplicity. In my experience, whenever I had to onboard a new member, they learn fast, if not immediately, on how React works. Especially with hooks, everything just became even easier. Performance. It's fast to the point you can get away with not using the different React optimization patterns. But of course, for the sake of pushing proper software engineering standards, be aware enough not to fall to that trap. Easy testing and awesome developer tools. Solves one problem only, powerful customization. I want to highlight this as much as possible, as this is the main reason I'm using React. Although for some, this may make learning harder if you jump into a complete stack, but the fact that I can combine anything I want with React will enable me to have full control of my desired solution. Of course, collocation is just easier to do this in React, given the component-based philosophy. Now let's jump to the core of this talk. As you can see in your screen, I've placed three different logos. These are open source toolkits and frameworks that will help you in creating your React application, as well as develop your React PWA. Let's tackle the first one, the green logo, which is Create React App, or CRA for short. CRA is the official supported way to create single-page React applications. The main key points in using CRA is what follows. Set up a pre-configured React repo. As you might have guessed, you won't see any Webpack or Babel configs. Everything is done for you out of the box. CRA assumes all you might need in doing the application. In addition to that, it has custom dev and build scripts. If you take a quick glance at it, it's a convoluted node script that makes use of different Webpack APIs. If ever none of this works for you, you can always eject to have access to the different configurations and scripts it currently has. Let's say, for example, migrating to Tailwind.css on an existing CRA project. Complete client-side rendered. This just describes how your application will render in the client side. The server that houses your CRA assets will just give initially one HTML file that contains your whole React application. Only when the JavaScript is fetched and loaded will the user see the first view of your application. Of course, it follows that there's one index in the HTML to rule them all. Why would I use CRA? If you need something that's quick and easy to set up a React application, use CRA. In my experience, it's near zero configuration since everything is already handled for you. No need for you to get your hands dirty on horrendous Webpack configurations. Well, most of the time. And also, like I said earlier, CRA has scripts for your initiation and build. Now let's go to the first juicy part of the talk. Let's learn to create a CRA PWA by building a store finder. Do pause the video to get that link below, or I hope the organizers / me in real life will post it in the comments. Alright, so you can see the Visual Studio Code here, wherein I will present the source code of the React PWA we'll be doing in CRA. And the React PWA we will be doing is the Stores Near Me application. So, as the header implies, are there stores nearby? If you click Find in My Location, it will show 20 different convenience stores near you. So, given that, you can also click View in Maps to open Maps.Google and just click directions for you to go to the pin of the store near you. Alright, seems useful. Now let's head on to the code. So the first thing you need to know is the index.js. So the index.js in CRA defines how your React application will be rendered to the physical DOM. So in this case, we use React DOM, which is a way for you to insert your React application through the physical DOM. In this case, it's just we're using the document get element API, and it's looking for a root div in the index.html. As you can see here, there's a div ID root here. This is where React DOM will insert your React application. So you can see here the JSX syntax that describes the structure of your React application. In this case, there are several components here that we actually use. We will go through them one by one very real quickly. So React.strict mode just show as a higher order component that just says that you use React in strict mode. Theme provider is a style component API, wherein style component is a library that can enable CSS in JS in your application. So in this case, like I said, React doesn't have an opinionated way that you can do styles, and I wanted to do CSS in JS for my application, one of which I can use style components. So theme provider is an API wherein it provides the theme for your application, and the theme here I just defined as an object wherein it describes the font sizes, different spaces, and colors of your application. And I highly suggest that you follow this pattern so that your theme is consistent throughout the views of your application. And whenever you want to change the theme or basically generate a dark mode, you can just change what is provided in the theme provider. There is also global styles component where it just describes the global styles. There's an API in style components called create global style where you can define the different global styles of your application. In this case, I have a global style for body and a before after stuff for the box sizing of my different containers. All right. Next is the router. So since React doesn't have a built-in router, like I said, in this case, I use switch router. So I define two paths here. One for the home, the index, which houses the app component, and one is the /store/position, denoted by a colon, meaning that position here is an actual parameter that we will be using. And whenever we encounter or navigate to /stores and /position, we can load the stores component. First, let's load the app component, which is the first view that the user will see. In the view, you can see a store image, are there stores nearby header, and the find location, which is very apparent here in the JSX syntax. I hope you appreciate that. Given that, we also created our own container for this, just so that we can center the content of the image and the headers. And I also follow an atomic design pattern, which will be apparent for all the PWAs that I will be doing in this talk, wherein it just describes different reusable components that describes a specific function. So in this case, for a box component, atomic component is just expanding to the width and height of the device. A button component, which is a button component, a card component that describes the different results. In this case, the each one, 2, 3 here is actually a card that stores the store data, and the header, we use as a header, a margin box that centers the whole application. Also, whenever you use the web view, it has a backspace of 1200 pixels. And the store image, which is store image, and the text, whenever there's text. So let's go on to the app. So I actually created my own hook here, which is use get location. Like I said, hooks are a way for you to access lifecycle APIs, and you can also create your custom hook so that you can reuse it anywhere you want, and it's just it just improves readability if you do so yourself. So the use get location is as defined is that we define two states here. So use a state in React is basically a data that you expect to change, and you want this data to be persisted across renders. So in this case, I need two states, which is the position state and the error state. So the use state hook actually returns the actual value of the state itself, which is the first item in the array, and the second item in the array is the callback to change the state. So in this case, a position and set position to change the position, error, and set error to change the error. And we're defining functions here. So the get location here that is actually used in the app.js get location. In this case, it's just checking if whether or not navigator.geolocation is available in the browser that you are loading the PWA on. If not, it's gonna set an error state that is not supported. And if it is supported, it's just gonna get the current position and the API mandates that you throw into callbacks. The first callback being the success callback, wherein it will pass the position. And once I get that position object, I can just set my state of position with the latitude and longitude limited by a comma. And of course, the error callback, wherein when then there's an error, whatever went wrong, I don't care for in this instance. I'm just gonna set the error to general. And any of this defined here, I will just pass through as a return value. And when I use it in app.js, I have access to get location callback, the position, the success, and the error state. Another React hook that you need to understand is the use effect hook. This case that I'm using here. So basically what it does is given a dependency or dependencies, whenever these dependencies change, run an effect. So there's two things that you can pass here. So a callback, which is the effect that we're pertaining to, and a dependency array. So this array defines what you will be watching out for. So whenever error changes here, for initially error here is null as stated here. So at the first run of the app component, it will not trigger an alert because in this case, I have a if condition here if whether or not error is null or whether or not error is true, to be more technically precise. And whenever error changes, and on the next render, error became a truthy value wherein it had something, a string from where we defined in use get location, it's going to trigger an alert. So this is easily shown here. When I turn off location, an alert will show that unable to get current location, etc. And of course, this will only trigger for the error state. If we want to track the success state, I'm just gonna load the success here and the position state here. And whenever position or success changes, I just need to check whether or not the success state changes. And if it did, if it's true, it's successful, you got the current location. In this case, if I activate the current location again, it's gonna load, it's gonna navigate to /stores. So in this case, it will navigate to /stores/position, of which we define in the index.js, wherein the stores component will be loaded if you navigate to /stores/:position, of which position is an expected parameter. So given that, let's load the stores component. So we expected that position will be a parameter. So in this case, I will use that position parameter to call a Firebase function that I created weeks ago to get the stores nearby. So to call that, I actually created another custom hook, which is use get store, of which is just use query, the hook in React query, of which React query is another library that helps me manage the states of my queries. So wherein I will pass in a promise request, of which in this case I use Axios, a library that I can use to fetch data from a backend, which will give a promise request. So in this case, Axios that get the Firebase URL here, and then you can get the stores nearby. And the position that I actually pass as a parameter is location, as it is the location that's defined here, and it's just a parameter for the Axios call to the Firebase function. And once the promise request is successful, I'm not gonna dig deep on how use query and React query works. But the main thing that you need to understand here is that it returns a query object wherein it houses the several callbacks and states of the query that we have done. So in this case, we will be using those we will be using the query object states that's defined in the use get state. Let me load stores right here. So I'm interested in the data, the loading state, and the error state. So, and I'm using use theme here, which is just another API installed components, wherein it just gives me the theme that I'm using. That was provided by the theme provider earlier. All right. So given the is loading state, so when React query gives me a loading state, it will just give me a loading state, which is this will be set to true. So if it's set to true, the view that I want to see is the swish spinner. You saw the spinner earlier, wherein it's just another library that I use called React Spinners List, just to show you a loading kind of UX. And if there's an error, obviously there's no error here, so because we loaded the results. But whenever there's an error, just give me a something went wrong. And placeholder here is just another defined container where it just centers my content. Given that, given everything is successful, nothing went wrong, we're just gonna load the results. So in this case, where you can actually use this kind of syntax to map the data, since the data here is an array, to a component that you want to create. So in this case, this ministop, core, and ls store, the lcore stores are several cards that have been defined in this data. And it just loads the card component, of which I explained earlier that it's just going to show the store data. One thing that to take note of in React, you have to define a key whenever you're doing this kind of pattern, because we need to let React know which of the components here is the actual identity of the key. Because if you don't give it a key, there is no way for React to know whether or not that element is the element you want to be removed or to be added. This way, the key gives React an idea on how to diff the current view, basically. All right. So the card just basically houses the several props, that number, name, location, and application that you can see here in the view of my mobile. And if you're curious for on how view in maps works, it just an anchor that targets blank, wherein it just loads maps at Google, and Android devices are smart enough to load the map application whenever this this href is being loaded. I'm sorry for iPhone users, you have to use Google Maps for this one, because I haven't considered using an iPhone for this one. Okay, so now given that you have a CRA PWA now you have to convert that PWA to something that's gonna work offline, something that you can add to your home screen, and define a manifest, of course. And that you can do all that through a service worker. Of course, I didn't change anything in there. It's actually included in the CRA setup. All you have to do is to register that service worker in your index.js. The main caveat of using the service worker of CRA is that it follows a cache freeze mentality, wherein the user have to close all available instances in their current device of the application before it can actually load the updated version of application. And of course, if you want to change that kind of behavior, you would want to update the service worker of the application itself. And given that, we're just gonna take a look at the public folder wherein there I define the manifest.json here. I use an online service called Doodle Manifest. This is where you can create your manifest.json through just filling up several forms, quick and easy. And then that's where you can define the different descriptions for your PWA. And given that, if that's HTML, don't forget to add the meta and the link to your manifest. And you can deploy this as always by just running the deploy script of the CI application and give the assets to whatever cloud service that you're going to use. Yes, that's it for the CIA PWA. Next up is NextJS. NextJS is the JavaScript React framework written by Zeit. Now we use the word framework here because although you can still combine almost whatever you want since this is still React, Next has built-in functionality that covers mostly what React lacks, of which I will list on the next slide. Next.js introduces server-side rendered pages. When Next was created, it solved the problem of doing SSR for you. It has its own built-in backend server out of the box, of which you have the option to deploy as is, and it automatically builds a server out of the box that renders your React application in the backend before sending the HTML file. Unlike client-side rendering, your app is immediately viewable on request, and once the JavaScript is fetched and triggered by the frontend, React has the capability to hydrate to the existing view, and that's only when it'll be interactable. And since Jamstack became a popular thing, it was just a matter of time for Next to adapt the functionality of exporting your React application into a static web application. I highly suggest that everyone familiarize themselves on how Jamstack works, as this introduces a much more scalable and cheaper front-end deployment architecture. In the newer version of Next, you could say it became a static site generator as well, or SSG for short. Next has an opinionated way on how you could do your routing, and for you to utilize the router of Next, you will need to use the library next/router, which is the routing library built in Next. Style-JSX is another CSS in JS solution that Next introduces, of which it is supported out of the box. But for the sake of being consistent across my applications, I'm still going to use styled components, and you will see later how I incorporated styled components in my application. It also has a bunch of APIs such as next/head, get static props, etc. I won't dive deeper in this for the scope of this talk, but you will use these APIs to let you customize how Next build your pages. And of course, for ease of development, one way for you to incorporate a setup to Next is through Next configurations, of which we will use one library to help with our PWA, as you will see later. Now, why would I use Next? I would argue that it is not an opinionated framework, although it does give a bunch of stuff out of the box that you will need for a complete application, but it exposes several APIs that lets you alter how Next works. Of course, one example later is how I use style components with Next. SSR and SSG for free. This will do wonders for your SEO, but there will always be an ever-long debate whether or not client-side rendering hinders SEO, with the ever-improving search engine crawlers, of which we won't be tackling in this talk. Built-in APIs that gives you control, performance. Since it gives proper code splitting and pages out of the box, performance will be evident compared to a completely client-rendered application. This is always my go-to whenever I have a product that will need to scale. As the API is bare-bone-like, I have confidence I have the capability to alter the behavior of the framework to suit my needs. Now let's learn to create a Next.js PWA by building a to-do list. Again, operators, give the link below, or the real me, leave it in the comments. Alright, now we'll be explaining the next PWA that we will be doing. And that PWA is a to-do list, which is much more simpler than the TRA PWA that we did earlier. Alright, so let's get started. I'll just quickly click the application here. Alright, so from the first view, you can imply one of the functionalities, which is to persist the to-do list, whether or not your application is closed or not. So as you may imply, you can just add a task here like clean the dishes. Press the add button, and now you have another task in your to-do list. Once you finish one of the to-dos in your to-do list, you can just click the check button, of which, let's say, I've already bought chips earlier. So just click the check button here, and that's where your to-do list will update and remove that buy chips. And as, like I said, it's persisting even though you close your application. Let's close it and open it. It's still going to be persisting, basically. All right, so let's head over to the actual code itself. So like I said, Next is a framework, so it has an opinionated way of doing things, one of which is utilizing routing under the pages folder. So whatever you define in the pages folder corresponds to a specific route and a specific view of your application. So in this case, I want the index route to host the homepage component that you see in your screen right now. So if you want to create another route, let's say list route, just create a list.js under the pages route. So given that, since we only have one view, we only need index.js. And before we dabble too much on the code of the index.js, we will be explaining some sort of Next APIs such as up.js and underscore document.js. So anything that is not preceded by an underscore will be processed by Next as an actual route. So in this case, underscore app.js describes how Next actually will build your React application or your React components. So in this case, I want to wrap all of the components that Next will build in the front end to have a theme provider and the global styles. As you can see here, this is tantamount to the index.js of CRA PWA. And I'm still using style components for the sake of being consistent across my applications. And I'm just using theme provider again to provide the theme and global styles to declare the global styles. And component here is whatever component you define under the pages folder, which is one of which is the index.js, of which it houses the homepage component. So the homepage component now has access to the theme and it's being global styled. If you want to alter the actual HTML that Next builds, you have to alter underscore document.js. So document.js here will help me solve one of the problems of using styled components in Next. So styled components, unfortunately, is not supported out of the box in Next. You might need to use a Next configuration to support that, or you can just alter underscore document.js to solve that flash of unstyled content. Since whenever your user loads your application without doing this, it will see a content wherein there is no styles. Since styled components is a CSS in JS solution, it will only load the styles once the JavaScript is fetched and hydrated to the view. So there will be a second or half a second wherein your user will see unstyled content, and that's bad for UX. And one of the ways for you to solve that problem using underscore document.js is to just alter how Next builds your actual HTML. And I won't be discussing the code snippet here that solves that problem, but to give you a high level of what it does, basically I use the API of style components that's highly available, called the server style sheet, wherein it just converts your several defined styled components into an actual CSS, of which you can actually just import it in the head of the next HTML document that you're creating. In this case, I'm using the get initial props for me to render the document and get the styles and insert it to the actual sheet itself. So given that, we now have solved the flash of unstyled content, so we need to go through the application itself. Okay, as you can see here, you can quickly determine how I did the view here. So here's your to-do list. There's a task input form where it just has an input form and a plus button, and a task list that houses the tasks list itself. So I'm still following the atomic design pattern that I discussed earlier. I have reused some of them, or what I use in CRA PWA, like the box and the margin box, etc. Sorry about the problem with the screen stream. I'm not sure what's happening, but regarding that. The other atomic stuff that I have created here is the card and the input, because I have an input form here and a task input, which defines the enter task here, and the plus button, and the task list, which has the task list itself. So just dashing through the custom hooks that I created here. Since we want to initially set the task list for the save task under local storage, I created a use get save tasks. So use get save tasks just fetches whatever task that I have saved in local storage. So in this case, whether if there is no task in local storage, I'm just going to return an empty array. And this is very important for you to check if window is defined, since Next builds your application as if it were server-side rendered, window is not defined. So local storage here will cause an error on build. So this snippet makes sure that your use get save task can only be accessed in the client side. So given that, the next step will be to save those save tasks under a state. So this one state here in this to-do list is the actual task list. This is something that is dynamic throughout the view, and we want to trigger a render whenever we add a task and whenever we delete a task. So that's the purpose of using a use state hook here in React. So as you can see, you have the task here, which just define the actual task, and the set task to update that tasks. So another hook that I created is use save task. So what it does is it just saves the tasks. So whenever, as you might guess, I'm just using use effect here, and the effect here is whenever tasks changes, I will save it to local storage. So whenever tasks suddenly increased in number or decreased in number, it will just save those tasks in local storage each time. This is very inefficient, but for the purpose of this demo, we'll be using this instead. All right. So one thing to note here, I created several callbacks like handle submit, of which this is something I will pass through the task input, since whenever I submit something on the plus button here, I want it to submit and append it to the task state that I have. So handle submit here just takes in a task object and just append it to the task list itself. And of course, the delete, wherein I using the index of that current list, using the index of that current item in the list, I will have an idea of what I will filter for the task. And like I said, always follow an immutable way in JavaScript, wherein this way you can make sure that your state will re-render, because if you use an immutable way of JavaScript, your state will have wonky behavior such as not updating accordingly in your renders. So I use the spread syntax to add a new type of array, immutable array, and I use task.filter to give a new task without the one that we want to delete, basically. Next is a task input. So task input makes use of another React API I want to introduce, which is use ref. So references in React is one way for you to access the DOM node of a component that you are creating. So in this case, since input, the form input or the input host component, as we all know in 11 HTML, has its own way of handling user data. Although you can control your input just by applying a value here and creating a state in React, which I highly suggest that you don't do. This way, whenever something is updated in the task here, I can just get the value, since I put a reference through the reference prop and just pass in the input ref that I have initialized earlier to have access to the DOM node input, of which is just an atom of a host component input. And from there, I can get the current value of that task input form. So given that, as you can see here, I just put a placeholder with the enter task here that describes enter task here, and a clear button that calls the handle submit that is passed by the parent. As you might see earlier, just to remind you, there's a handle submit here that just takes in a task and appends it to the task state that we have. So given that, once you click the button of plus, it will click handle submit, and the handle submit here is just a callback that I define in task input, of which it will just call the callback that the parent submitted and give the current value of the reference. So the current value of the reference is what the user inputted in the first place. And since I want to clear that input form whenever I submit something, I'm just gonna set the current value to an empty string. That's it for the task input. Now we head over to the task list. As you can see in the index.js, we pass in a handle delete callback wherein it just takes in an index. And since we know we're gonna map the tasks here, we will have access to the index. And we're just gonna filter the task that we have to not include the one in that index. Given that, I'm just gonna pass the tasks here and the onDelete callback to the task list. So here, as you can see, I'm just mapping yet again, another card component, of which is customized for the to-do list right here. And the card component takes in a text, which describes the text, which is clean the dishes, and an onClick, which defines the delete callback. In this case, I want to map the task itself and the index itself so that on the onClick, I can just specify to call onDelete given its index. And of course, don't forget to add a key. And since I'm against using indexes as keys, just append a string here to make sure that your application is much more stable when it comes to creating mapping React elements, basically. All right, so I guess that's it for the actual functionality of the application. Now we head over to actually converting this into a next PWA. So one way for you to alter how Next configures the application is through next.config.js. So this is one way for you to, hang on, the screen stream is malfunctioning since I closed the application. All right, and one way for you to actually create the next PWA way is to call libraries such as with PWA here. I use next PWA, a library, a next config library that handles the PWA functionalities for me. In this case, whatever you import or export in nextconfig.js, it will follow some sort of recursive pattern wherein you just have a barrage of function calls, of which this will define how your PWA will work. So in this case, I will call with PWA, and the actual config that I want Next to use is PWA, and the destination is the public folder. So whenever this with PWA config is ran, it's going to append the current service worker, which is already minified, as you can see, and the workbox minified version, which is workbox, what the service worker uses out of the box for it to become a PWA. As you can see, also in the public folder is where I define the manifest.json, and in the document.js is where I define the meta of where the manifest.json lives. So anything you put in public is defined as the root. So anything you put in public can be just accessed by a slash something. So slash manifest.json to access manifest.json. And manifest.json, as you may guess, just houses the icons and the description of my PWA application. And whenever you want to deploy this, it's going to export. Make sure in next.js, whenever you want to actually build it as a SSG, you would want to build it first, then export it to create the out folder. The out folder defines the static assets of your application for deployment. In this case, the index.html is what we defined here in the index.js. And as you can see, the head has several data styled components here, which is created by the _document.js here, this snippet here, to prevent that fork. And the several assets that we define in public, and the manifest.json, the service worker, and the workbox minified version. That's it for the next. Now let's head over to the great GatsbyJS. GatsbyJS is a React-based GraphQL-powered static site generator, and of course, open source by Gatsby, the company. So the unique thing about Gatsby is that it's a purely static site generator, unlike Next where you have an option to use a server-side rendering backend. It's also a framework, so unlike in Create React App, Gatsby has a way for you to create your routing, your styling on its own, rather than incorporating other libraries, unlike in CRA. It's also opinionated on how you could access internal data in Gatsby. I won't be showing an example of that for this talk, but let's take note that Gatsby enforces GraphQL as your main mechanism and dabbling with its APIs. If you're not familiar with GraphQL, I highly suggest you look it up as it's one of the most powerful ways for you to handle your backend requests and internal data handling for your application. Gatsby has its own internal routing pattern, of which it just uses @reach/router behind the scenes. If you recall, this is the routing library I used back at CRA PWA. Several lifecycle APIs that helps you guide Gatsby on how to build your site, similar to app.js and document.js of Next. For example, we have Gatsby-ssr.js and Gatsby-browser.js, etc. Gatsby plugins. This is the core feature of Gatsby that explains its philosophy of making web development easy for everyone. If you have a certain problem in your Gatsby application that needs solving, there's a good chance the community already created a Gatsby plugin for that. You may also create your own locally if ever the need arises. Gatsby Themes is just a type of plugin that will alter your overall application out of the box given whatever theme that you choose. For example, you choose a store Gatsby theme that will alter your whole Gatsby application to look and work like a store website. Tooling philosophy is the mindset you need to adapt in Gatsby, as it's the main pattern you'll be following throughout the Gatsby ecosystem. This just summarizes what I said earlier about Gatsby plugins. Now, why would I choose GatsbyJS? It's freaking dirt easy. Use the CLI to initiate and use the Gatsby CLI again to build and deploy. Not to mention its specificness to SSG makes it easier to do Jamstack and deploy to static assets cloud providers like Netlify and Amazon S3 behind the CloudFront. If ever you come across a Gatsby specific problem, there's probably a plugin for that. Need your images to be sharp and optimized? There's a plugin for that. Need to use styled components? There's a plugin for that. Need to create a PWA with offline capabilities? There's a plugin for that. Of course, it's also an static site generator. You get it for free. Again, SEO wonders. And to summarize, it's my go-to for almost every typical lightweight site, such as marketing websites, blogs, and landing pages. Now let's learn to create a Gatsby PWA by creating a mirror app. I know it's a very watered down application compared to the other applications we have created, but the purpose of this is just to introduce to you how Gatsby can be quick and easy. And also, I might be overloading your brains with the concepts I've been throwing around. So again, operators, give the link below, or the real me, give it to the comments. Alright, so in front of you is the source code of the Gatsby PWA that we will be doing. And of course, the application that we will be presenting is a see your face application, or in short, a mirror app. So the first view is it asking you to enable the mirror. Of course, it's just proper practice that you ask permissions first before accessing any native device, such as something as private as a camera. So here I click the enable mirror, and you can see here, you can now see my face. All right, so that's basically it. So that's basically how the mirror app will work. So let's just dabble with the code. Just like you can see a bunch of patterns here that is similar to Next. The screen stream will stop because I locked my phone. But here you can also see a pages folder. It's the same as Next, wherein this defines the routes of what will Gatsby build. So one file here defines one route in your application. Since we only have one view, of which is just alters between a button and the mirror itself, we just have here index.js. And as you can see here, I'm reusing the atomic design patterns that I did earlier, and I'm just using again the box and the margin box that I created earlier. and I create a button for the button and the mirror for the mirror. So that defines the pages. So once you load slash or index, it will load this basic view. Now, we need to find the pattern on how we use it next. So next we have underscore app.js, but in Gatsby, we have Gatsby browser.js and Gatsby-ssr.js. So what this two Gatsby API does is that for the Gatsby-browser, anything that you place there, for example, the root element here, you can see again that we have a theme provider as well that we use in styled components, the global styles as well, and the element. So the element is anything that you defined under pages. So in this case, index.js, the homepage component is the element in the root element. And for Gatsby-browser, so what this does is it wraps the client-side React application. So in this case, we have a root element for the client React side of things, wherein whenever it tries to load the index.js, it will wrap it around first the root element, which just says wrap root element. In this case, we define it as just wrap it with a theme provider, which you might guess just gonna provide the theme again under side components and around the global styles. As for SSR, this is where you define most of the time. This is as the same as the Gatsby browser and you don't want them to be different. But sometimes you just want things to happen in the browser side of things and some in the SSR side of things. In the SSR side of things, this will be resolved in build time. So whatever you wrap around this at SSR, this will generate the actual HTML view at the first build of your Gatsby application. So just summarizing, browser for the client side and SSR on build time. Next thing you have to know is that we have this plugin mentality in Gatsby. So where do you actually define these plugins? It's under the Gatsby-config.js. As you can see, I've been using several plugins to make my life easier. Here I'm using the plugin React Helmet for my meta, the plugin style components to make my style components work, else I will have that fork problem again that I had in Next. Gladly in Gatsby, we have already a plugin for that problem, which is to just use the Gatsby plugin style components and the transformer and plugin sharps for all my assets pre-initializations and optimizations. And of course, the Gatsby plugin manifest that just defines the manifest that Gatsby will be using in your application and in for your PWA. And here you can put the options such as my name, short name, the every description that you need for your PWA to work. And well, not work, but rather the different details to make your PWA look good. And of course, Gatsby plugin offline to make your Gatsby application available offline and to be added to your home screen. And yes, that's it. That's how you can create it to a PWA. Now let's just go into the code real quickly. So index.js just calls the mirror application. And I'm sure you're already familiar with box and margin box, which has been the atomic or the atoms that I've been using throughout my application. It's just the same. I didn't change anything, as you can see, still the same. And let's load the mirror component in here. All right. So first of all, I'm gonna use a reference for my video reference, because here the video ref right here is actually just a style.video. Video is an HTML element you can use to stream stuff basically, or you can just put actual video file in that video element, and there you can actually create that video element. In this case, I need a reference to that component because I need to feed it a source, of which the source is my camera. For me to know the camera, just a little bit of information here. First, I need to set the state that the permission is granted for my Gatsby application, because I don't want to assume that we can use the camera immediately. That's why I need to put a state wherein it's permission granted or not. So in this case, every time you open the application, it will ask for permissions first, as you can see earlier in the demo, wherein only after clicking that button will you be able to access the front camera. So in this case, it's just a simple state. And of course, if it's not permission granted, show the button to allow the permission. Else, after, if ever the permission is granted, you can actually show the video reference. In this case, I pass in a props of show, of which it will just update the display to block or none. If it's display none, it's not gonna show. If it's display block, it's gonna show, basically. Let's say we have permission granted. So how do we actually ask for permission here? So I did an async function here, async await function here, and we're just gonna use navigator again. So I have a check for is browser again, because we don't want to run, since Gatsby is also SSG and it's gonna try to build your application before giving it to the actual user. If it encounters navigator here, and we all know that navigator doesn't exist in the back end, only in the front end, this is only, it will cause an error, just like local storage. It will cause an error on build time. So that's why we need to check if ever the current build is in the browser or not, just to avoid that error. Now let's say everything is well and done. All we have to do is try and get the media device wherein it's facing the user. I use the word exact here. You can use a bunch of other keywords, but exact meaning it can only use the front end camera. Else you will throw an error if there is no facing camera. So given that, once you give this streaming, you need to give the video reference, the current source object of that video, wherein the navigator can fetch that stream for you. And that's where you will apply it to the source object of the video. That way, the video will display whatever the stream source is. In this case, this is how I set it up. Next, of course, once you give it the source object, you need to let it know that you are actually streaming and you need to play it. So you need to, in the current reference to the DOM node of video, you need to hit play. In this case, video.ref.current.play. And of course, once you play it, I need to set the permission to true. That means the video is finally ready to be viewed. And that's it. Just a big tidbit here, because you can see it's very, very big. Because for some reason, I can't really alter the width and height of the video. So what I did was I transformed it to -2.5 because the current video itself can't handle, it's not smart enough to know whether or not your orientation is to the left or right. So right now it defaults to the left. So it's to mimic a mirror image, I need to scale it by -2.5 and just scale the Y as well so that it can occupy the whole screen. And I'm pretty sure if anybody has a larger device, it's not gonna work. It's just gonna have some sort of white background on top. But in the case of my cell phone, I just needed it to fit the whole screen. All right, I guess that's it for the Gatsby PWA. It's very quick and easy on how you could create one. As you can see, I didn't do any special stuff. I just added the plugin that I need for creating the PWA and making it available offline. And as you can see, this is how Gatsby works. You just need to define a bunch of plugins and create your own views using those plugins. All right, so that's all, folks. I hope you enjoyed my talk. If you need to know more about me and what I do, just visit my website at fsicon.dev. It's currently a crude version of my website right now because I haven't found any time yet to improve the concept of the site, but all of the necessary links is there for you to contact me and to learn about what I do. And there's also a link there for my LinkedIn, wherein I post all of my materials in LinkedIn, so you can just get it there. And of course, all of the applications that I have shown you is open source. Just visit my GitHub account that is also linked in my website below. All right, so I'll leave it to you on which of the three you're gonna choose. I fairly gave all of my opinions regarding why would I choose one. It's up to you on which one you're gonna choose. And that's the beauty of React. You can just use about anything. And I'm pretty sure there are other frameworks out there that's built on top of React that you can use. And hopefully you can choose what's your favorite. That's all, folks. Thanks for watching.